Okay, today we're going to look at lessons 6.4 and 6.5. So in lesson 6.4, we'll be looking at how to determine if two quantities are proportional or non-proportional. And then in lesson 6.5, we'll look at how to actually solve proportions to find a missing quantity. So two quantities are proportional if they have a constant ratio or rate. And then if the ratios or rates are not constant, then the quantities are non-proportional. We have two tables here that look somewhat similar. One is the cost of cell phone plan A, the other is the cost of cell phone plan B. And they both give you the minutes and then the cost for each of those minutes. And if you notice on both of these, one thing that's similar about them is that they have the same difference in each of the columns. So 400 to 600, 800, 1,000. These are going up 200 each time. Same thing with the dollars. If you look at 32 to 48 is going up $16. This increases another $16, another $16. And these have the same change as well, increasing by $16 each time. So that alone, I know a lot of times we're kind of trained to look for that first, but that alone is not enough to tell if something is proportional or not. What we have to look for is the ratio or the rate between the two things in the table. So let's look at that on cell phone plan A. So the first column we see, for 400 minutes, it costs $32. So that's $32 for 400 minutes. And in order to compare these, just like we did at the start of chapter 6, in order to compare two things that have different, different numbers, in order to compare the two rates, we're going to need to have a unit rate. So we'll want to go ahead and simplify these so that they have a denominator of 1. So we'll divide both of these by 400. And this will come out to 0.08 over 1 minute, or 8 cents per minute. Okay, let's do the same thing with the second column. So this is $48 for 600 minutes. And again, we want a denominator of 1 so that we have a unit rate and we can compare them. So this becomes 0.08 over 1 minute because we divide both of these by 600. And again, that's 8 cents per minute. So it looks pretty good so far. These have the same rate. Let's go ahead and keep checking the other two though. This is $64 for 800 minutes. And that, when we divide to get a unit rate, that also comes out to 8 cents per minute. So let's check the last one, $80 for 1,000 minutes. Again, 0.08 for 1 minute, or 8 cents per minute. Okay, so now we see that these are all 8 cents per minute. So because the rate is constant, we can say that this relationship is proportional. Let's see what we get in the second table. So we'll do the same thing here. So $28 for 400 minutes. We divide these both by 400. This comes out to 7 cents per minute. For the second one, we have $44 for 600 minutes. But when we divide these, this comes out to 7.3 cents per minute. And this is actually 7.3 repeating, so this is rounded off to 7.3. So I'm going to use the approximately equal to symbols. So it's like an equal sign, but with squiggles instead of the straight lines for equals. Then the next one's $60 for 800 minutes. When we divide these, this comes out to 7.5 cents per minute. And then the last one, $76 for 1,000 minutes. And this comes out to 7.6 cents per minute. Okay, so we can see from this table, when we look at the rates and compare them, these are not the same. These are not constant. So because these rates represented in the table are not constant, the relationship between the two quantities is that the quantities are non-proportional. Okay, let's go ahead and do the same thing with examples 1 and 2 to determine if these are proportional or not. So determine whether the cost of baseballs is proportional to the number of baseballs. So here we have $2 for one baseball. So $2 for one. Which comes out to $2 per baseball. The second one is $3 for two. So $3 for two. When we divide those, that comes out to $1.50 per baseball. Well, the question has to determine whether the cost of baseballs is proportional to the number of baseballs, but if these already are not the same rate, it's not going to matter what the rates are for these last two, because this clearly is not constant. So this one is non-proportional. Okay, and let's look at example number 2. Determine whether the number of meters is proportional to the number of seconds. So in the first one, I have 24 meters for 1 second. So as a unit rate, that's 24 meters per second. In the second one, that's 48 meters in 2 seconds, which when these are divided, comes out to 24 meters per second. So the same so far. 72 meters for 3 seconds. And again, divided 24 meters per second. And the last one, 96 meters for 4 seconds. Again, when these are divided, comes out to 24 meters per second. So in this one we see that each of these rates is constant. This is the same throughout. So we would say that these are proportional. Okay. At the bottom of the page, there are two for you to try on your own. So what you're trying to do is determine whether the relationship shown in each table is proportional or non-proportional. So do the same thing that we did in example 1 and 2. Check the rates in each one and see if they're constant or not, and then determine if the relationship is proportional or non-proportional. So go ahead and pause the video, work through those two problems, and when you're done, go ahead and hit play to restart the video, and then you can figure out if your answers were correct or not. Okay, so for the first one, you should have gotten that this relationship is proportional. But in the second table, this relationship is non-proportional. Okay, proportional relationships can also be described using equations of the form y equals kx, where k is the constant ratio or the constant of proportionality. Okay, what this is telling us is when the relationships are proportional, there's a special property that exists between them where you can actually represent them with an equation. Because they have that proportional relationship, we can find this constant just like we did in the previous page where we found the constants for, we found that constant ratio for each of those tables that showed something that was proportional. If something is proportional, that constant ratio becomes part of this equation. So we'll see what that looks like in example 3. It says Nina charges $34.50 for 6 days of pet sitting. Write an equation relating the cost of pet sitting to the number of days. What would be the cost of pet sitting for 4 days? Okay, so just like we did in section 6.2, where we wanted to find a unit rate, we're going to want to do that for this also, because we want to know how much she charges per day. We know how much she charges for 6 days. We want to know how much she charges per day, or for 1 day. So let's start by finding that. So we have $34.50 for 6 days. And again, to get a unit rate, we want this to have a denominator of 1 day. So we'll divide by 6. And $34.50 divided by 6 will give you $5.75 per day. Okay, so this is the constant rate that she's charging per day, or we can also call this is the K that will be part of the equation, or we can call this the constant of proportionality. Okay, now to write an equation relating the cost to the number of days, our equation will look like this, where K now we know is 575. Now in our case, if you look at what this says she's charging $5.75 per day. So 575 times the number of days. So the x in this equation will represent the number of days. So that means the cost, C, is equal to 575 times D, the number of days. So, and this fits the format of this equation. In this case, we don't have y, we have c for cost. K is the number we found for the constant rate, and x in our case is the number of days. So this answers the first question. Write an equation relating the cost of pet sitting to the number of days. Now from here, if we want to find the cost of pet sitting for 4 days, this is days, so this will replace the D in our equation. So C equals 5.75 times 4. And then when we multiply these, this will give us that C is equal to, the cost is equal to $23. Alright, and then 3A here is for you to try on your own. So go ahead and pause the video, work through the problem, and when you're ready to check your answer, go ahead and hit play to restart the video and you can check and see how you did. Okay, so for this one, the equation you should have come up with should say C equals 2.88p. The cost is equal to $2.88 times the number of pounds. And then the cost for 4 pounds, cost would equal $11.52.